the first video, we have explained or we have discussed about what an LLM is and how does an LLM sit top of a transformer framework and how does it function, like what are the basics of LLM and what is the purpose of LLM, why was it at the first instance, why was it created, and how does it help us. So all these questions we have discussed in the first video. Please check the first video of this series to understand the basic idea about LLM. Now in this second video we will be discussing, or I will be explaining some more entities or some more terms which are revolving around LLM. Now I have these noted down, like all these points I had put in the first video. Let me just move those items which we will be discussing in this video. We will be discussing about prompts, we will be discussing about embeddings, we will be discussing about tokens, we will be discussing about vector store. So in this second video, we will be discussing about these terms, and in the last or in the next upcoming video, we will be discussing about the remaining, these four remaining terms. Now let's talk about, let we have this final result, or this is the final part of our first video. Let me do one thing. Now we have understood what is an transformer framework, what is an LLM. Now let me just zoom. I will just remove this, I will remove this, and I will zoom an LLM. So let's go inside an LLM and see how it functions. So let me just move this. I'll just copy both these. Just a second. I will copy both these. I'll slightly move them here. Now let's talk about an LLM. I will just rename it to LLM because we are just going to cover any general LLM which sits on top of a transformer framework. Okay, so I will call this as a transformer framework. Okay, now we will discuss any LLM, how does it function, how does it interact with these four entities. Okay, so let's take an example of an LLM called ChatGPT or Llama 2. So these are all different LLMs. Now each LLM is nothing but a program, and it takes an input and it returns an output. Now let's say we have an input. Okay, so this input is coming from a user. Let's say we have built a chat application. Now this chat application will be used by any user, and a user will interact with this chat application through text messages, and a user will expect the chat application to respond back with the text response. Now let me briefly explain in terms of how the LLM fits into the equation of web development. Like, see, in terms of web development, we basically have front end, which can be a React application, an Angular application. So let me just put it here in simple words. So let's take about, we have in a basic web application, we have components like, we have, say, front end, which can be a React application or an Angular application, and then we will have a backend. Now This backend can be a Node.js application or PHP or .NET application. So the interaction between a front end and back end application is going to be through, say, GraphQL or REST API. Now this backend application is either it is going to be like we will have a different process or a different server which will be running our LLM. Now, this application will interact, or this service will interact with our backend service. So, there will be to and fro communication between our backend service and the LLM. And now, this LLM is going to be using lot of other data, like this can be our own private LLM, like we can pick up an open source Llama 2 instance and host it on our own AWS server or on our own proprietary server, and then train that LLM with lot of data with our own private data using a RAG model, which I will be coming to later. But let's assume that we have this LLM which is running on a separate private instance, and we can this LLM will be like fetching data from different sources, or it will be trained, or it will be, in other words, it will be fetching data. Because see, this LLM, so what is the difference when we say an LLM is trained on a data or an LLM is using data? So when we say an LLM is trained on data, that means we have provided an LLM with the data. It has trained itself. That's it. The process ends there. But when we say the LLM is has access to the data, or to our private data, or to an internet data, that means the LLM is not trained, but it has access, or it can connect to the other data through a setup which is called RAG. So using RAG, we can have the LLM connect to other data sources. So this database can, or this API, sorry, this API can connect to an LLM, and it can function on its own as well using its own database, or it can function using the same database which we are using for an LLM. So this is the basic setup where an LLM fits in to an existing or to a new web application. So let me just delete this, and I will go back to our main diagram, which is this diagram. Now, when a user needs, and this user is an end user and he is our business user. Suppose we are building a like a customer care kind of web application where a customer comes into our website and enters some text and wants to interact with a chatbot, and this chatbot is built using an LLM. Now this customer is going to send the question to the LLM. Let's say, like, I will just put it here, and I will make some room for the question. So let's say the customer is going to ask some data, some questions. So it would say, uh, which stock had the highest profit profit today. Okay, so when the user is asking this question, so there is a specific reason I have put this question in inside a box, and I will come to that later. So when this user is asking a specific question, this question to an LLM, now LLM will need to understand what which stock the user is referring to, or what is what is today's data which I have to analyze in order to send back the correct response to the actor. So there are a lot of things which we have to pre-process before we send this specific question to the LLM, actual LLM. Now that is where the first point, that is where the prompts come into picture. So let me just I will just zoom out a bit so that we can fit in some other things in this diagram. So let me just say we have one more diagram, one more section. Now this section will host these two. Now just cut this. So these two sections or these 2 points will come inside this main section. Okay, let me expand this a bit. I will drag this inside in here. Okay, so now this is our actual prompt. Okay, so we will just close it. And now what happens in here is this, our main prompt or our user is going to interact. So let me zoom in a bit. So this user is going to interact with our service, so that this is going to be our backend service. So I'm just going to name it as our backend service. It can be a node service backend API. I will call it as a backend API. So it can be our node service or it can be any API. So this user is or customer is sending us a message or a text question. Now till now this is not actually a prompt. Now it will have to follow certain guidelines to become a prompt, and that is where the AI developer comes into picture. So what does AI developer do? AI developer takes in this request. Like what it does is it converts this text, into an actual prompt. So here we can see forward, sorry. Okay, so we'll see send back. Okay, just a second. I'll just go here and I'll just click here and I'll say spring front. Send back should be coming. Okay, let me take a new box. Okay, so this is where the developer will convert this text into a specific prompt. Now what does the prompt mean? So the prompt means a developer will take this question and will have a specific template which we call as a prompt template. Now the developer will send this question as part of a larger question with a which actually uh, has a particular template format. Now the question can be like a developer can, we can have a template which will have a format with context and question. So when we say about what is a context, so context is nothing but it tells the LLM what data do you need to use in order to understand this question. So suppose the question is which stock had the highest profit today. Now which stock? So the LLM needs some understanding about the stocks it needs some understanding about the stocks which fall today, like which are related to today. So based on this data, it will this data will become the context for this question, and the context will be part of the template. Now this selection of template and the question is decided by the AI engineer. Now this context and the actual question is sent as an envelope, is sent in a kind of an envelope or packet to the actual LLM. Now this is sent to, sorry, this is sent to the, this is converted into a prompt, and this prompt is then actually sent to the LLM. So in our backend API, which I will try to change the color for, okay, let me just change it to say this. Okay, so this is our backend API and this is our LLM. So this prompt gets converted, this message question gets converted as a prompt to the actual LLM. Now, using this LLM prompt, well, this is prompt, the LLM will pick up the context. So context can be any data. Suppose we are feeding in a CSV file data or a PDF file data, we can uh, send a context to the LLM stating that this is the PDF file, and any question which is asked you, you should respond based on the PDF file. So it will pick this question and it will check the question and it will convert this question into different uh, entities like embeddings, vectors, which I will come to next. But it will understand the question based on the context and it will respond back. So this is basically how the LLM functions in terms of prompt and context, and how it fits into our web development framework. Now in the next part, what we will do is we will understand how this how the internal workings of LLM happen, like how does an LLM function internally once it has received this prompt or context or question. How does it function internally? So what does an LLM do? So see, LLM is just a program. It is not a human being who is sitting somewhere, who has got this question and he has understood what you are saying. It is just a program. It needs some way to like understand this question, understand the context, break down this question piece by piece and or word by word, and then understand it in its own way, and then give you an answer uh, like you will receive the end user will receive the answer in a way as if it has been as if there was a human being who was sitting somewhere and who is responding back. So that is how the LLM will function. So for this end user, it will not, he will even not notice that he has got a response from a program rather than from an actual human being. Now, so how does LLM do that? So LLM does it using embeddings and tokens. So let's talk about embeddings and tokens. So when we are asking an LLM this question, which stock had the highest profit today? So what does LLM internally do? LLM internally breaks down this sentence or this question into smaller tokens or smaller words, like an one word or two words. Based on how the LLM is configured, it can create, it can break down these words into tokens, and even the question mark can become a token. So the capability of an LLM, so if you check on OpenAI or ChatGPT, it will have a specific program called tokenizer where before you send an question to the ChatGPT, it will ask you to calculate the tokens. It will have a restriction of tokens, or it will charge you based on tokens, and that calculation or those tokens are calculated by breaking down the sentence into words and then converting those into tokens. So this sentence 1, 2, 3, 4, 5, 6, 7, 8. This sentence can be 8 tokens, or it can be broken down into 8 tokens, and LLM is going to charge you for 8 tokens, and also it charges you based on the output response. So this sentence is actually going to convert it into tokens. That is one thing, and then the other part is this sentence is converted into embeddings. And now what are embeddings? Embeddings are nothing but those are vectors, like multi-dimensional vectors. So let's consider that we have an let's take we have an coordinate. So when we talk about coordinates, we have like on a graph we have x is equal to 10 and y is equal to 20. So when we say x is equal to 10 and y is equal to 20, so these are coordinates for a point on two-dimensional graph. But when we are talking about multi-dimensional, so it refers to space. So when we have like a embedding or a vector, it is converted into an coordinate which is in space. So it's a three-dimensional or multi-dimensional like space where we can plot that embedding or a vector, and then based on the like we can compare the different like distance between two vectors in that multi-dimensional space and decide that if a vector is closer to the other vector, that means it is similar to that vector. So its similarity is decided based on its closeness to the other vector in the multi-dimensional space. So that is what is actually an embedding. So what does an LLM do? So we delete this and create. So what does an LLM do? LLM first converts this question into embeddings. Now embeddings are, these are like multi-dimensional, like these are vectors which are represent multi-dimensional points. Now now once we have these embeddings, it's see okay, so now these embeddings have to be like, once we have these embeddings, now based on these embeddings we can at some place. So what we can do is we can say, let's take these embeddings. We can finally, let's see, basically LLMs don't have any persistent storage. So they are stateless. So ideally by default, an LLM is nothing but a stateless program. It doesn't maintain any history, or it doesn't maintain any storage to save this context or to save any other data which it requires for processing, like these embeddings. So what we can do is we can store these embeddings in a separate persistent database which is called a vector store. Now a vector store is nothing but it is a persistent storage where we can save these embeddings. Now these embeddings will finally go to a vector store, and they will be then processed, or they will be then sent to the LLM from the vector store. So what we can do is we can have these embeddings stored in a vector store, and then once these embeddings are stored in a vector store, we can then send them to the LLM. So the vector store, or we can in other words say that our backend API is also responsible for communicating with the vector store and fetching the embeddings and sending those embeddings to the LLM. Now it can be like this. So that is how we will define the architecture of an LLM with respect to a prompt, a vector store, and an embedding. So this is how the broader picture of an LLM works, and in terms of its basic components related to prompt, vector store, and embeddings. Please subscribe to my channel and I will post new videos about the other concepts of LLM. Even more exciting stuff is coming up with regard to demos of other features. We will be discussing in the next video about RAG, agents, pipeline, LangChain, Llama index. All these features will be discussed in the next video. Thank you very much.